Hi, greetings, esteemed viewers. It is a great pleasure that we welcome you to Volt and Ampere Diaries. We humbly request your support by liking and subscribing our channel. Let us embark on a journey of growth and progress together as we strive towards achieving our goals. Thank you for choosing to stick with us. Today we are going to learn about electric motors. As we all know, electrical motor plays a vital role in the organization. So today's topic that we need to cover is the introduction part. Next, what are the industrial motor types? Then, what are the motor characteristics, the losses made by motors? What are the efficiencies, factors that affect the motor performance, rewinding versus replacement of motor, and energy saving opportunities? Coming to the introduction part, what is a motor actually? A motor converts electrical energy to mechanical energy. Okay, and how it is converted? It is converted by interaction between magnetic field setup in the starter and rotor windings. So basically, what is a motor? A motor is something that converts electrical energy to mechanical energy, right? It's over. And how it is converted? In motor, there are actually two parts. That is a stator and a rotary part. So the stator part is the static part of the motor, while this rotor part is the rotating part of the motor. The stator never rotates. Okay, it is stable in its own place. Whereas in the rotor there is the rotating part. What is actually the rotating part? It actually there is a magnetic field between the starter and the rotor. So by the help of that, the rotor moves. Okay, in the further lessons, we are going to learn how it works. Okay, basically, industrial motor types. We use three types of motors in industries, and they are induction motor, DC motor or direct current motor, and the third is synchronous motor. Induction motor. A induction motor has a fixed outer portion called the stator and the rotor. Before this, we have already learned about the stator and rotor. Right now, come to this portion. How actually these things looks. So this is the rotor part. We can see here. This is the rotor part. Right. It is the rotor part. Let's take a pen. It is not clear actually. This is the rotor part, and here it is the stator part. Right. How this rotates? This is basically rotates because both of these have an engineering gap. And let's see, you can see this. There is an engineering gap in between this, so that both of these get a air gap and the rotor can move freely. Now it is moving freely, right? So how it rotates? The magnetic field produced in the rotor because of induced voltage. How this magnetic field created? Because of the induced voltage, a magnetic field is generated in the alternating nature to reduce the relative speed. With respect to the stator, the rotor stator running in the same direction as that of stator flux. So how this rotor rotates? Actually, whatever the when the stator, when a voltage is induced, a stator gives a flux in a direction, and in the same direction the rotor starts moving, right? When the rotor starts moving, it tries to catch up the speed of the stator field, but it never succeeds. And the fun thing is that there is no external electrical connections to the rotor. So coming to the point, we will conclude it now with the induction motor page. So this is all about working of induction. We'll later on know about other motors as well in the next section. If there is any doubt or if you are willing to learn with PLC as well, we'll be continuing it very soon. So, thanking you for today. We'll be continuing it tomorrow. Thank you.